Okay, let's define what a polynomial function is and is not. Now here's our formal definition of it, where we have a sub n's, x to the n's, plus dot, dot, dot. Don't get intimidated by this. Most students look at this and they're like, boy, that's a different language. That freaks me out. I don't like that definition. I am shutting down. All right, we can't have that with this. All right, that's the general way to write this. But what you want to be careful about is that n, our exponent, is going to be a non-negative integer. All right, so meaning that it's going to be non-negative, that means we can't have any negative exponents. All right, so we may have seen in the previous videos that you can move a variable from denominator up to the numerator and make it into a negative exponent. That's not going to be the case here. So no variables in the denominator. Okay, that's one thing to be looking for that would exclude it from being a polynomial function. The other thing is it's an integer. Okay, so integers, we're thinking like 0, 1, 2, 3, 4. Those all fit into our definition here. Okay, so we can't have any fractions up in the exponent. As we saw in a previous video, like a square root can be rewritten as 1/2 as an exponent. So if you have any radicals hanging out on top of your variable, like x here, that wouldn't be allowed for it to be a polynomial function. Same thing, can't have any decimals up in the exponents either. All right, and that goes for all of the terms along the way. So don't get thrown off by that. Terms, we refer to those as being separated by addition signs in between. So you can have multiple different terms in a polynomial function. As opposed to a monomial function, we're limited to having a single term. So polynomial functions, poly means many. All right, next up, let's go ahead and look at a few examples real quick and see, is this polynomial function or not a polynomial function? So we'll bounce around and explain yes or no. This first one actually does work out to be a yes. It's a yes because we don't have any radicals over top our variable, no negative exponents, no decimals for our exponents on the variables. So that one fits all the bills to be a polynomial function. On the next one, however, we have k of x equals the square root of x. You could rewrite this as x raised to the 1/2 power. That would break our rule about having a fractional exponent or a non-negative integer exponent. So we'd have to answer no on this one. Okay, on part C, we have big F of x equals x squared minus 2 over x cubed minus 1. We said we weren't allowed to have fractions or rational functions going on here. This x to the third being in the denominator is a bit of a problem. Now, if this had all been a constant in the denominator, that would be okay. But because we have the x down here, we have to answer, nah, that doesn't fit into a polynomial. Now, two more that are a little bit trickier. G of x just equals a constant function. In this case, it's just a constant function. It actually gets a yes as far as is it a polynomial or not. Let me see if I can show you why. We would all agree that 8 is equivalent to 8 multiplied by 1. And 1, using an exponent rule, anything raised to the 0 power is equivalent to 1. So this could actually be rewritten as 8 multiplied by x to the 0 power. This would be a degree 0 polynomial. We'll talk about degrees in just a second, but this would be a degree 0 monomial because it's a single term. And monomials are polynomials. All right, h of x, the last one we're going to go through in this video, we've got to be a little bit careful here. We've got a couple things multiplied together. If we actually take the time and multiply this out, this will be a little bit easier to see that it actually is a polynomial. By that, I mean we can write 2 copies of x minus 1 multiplied together, right? That's what an exponent means, is that many copies of the base multiplied together. And then take our time and multiply this out. We'll say negative 2x cubed. And then what's on the inside there, we're going to go ahead and go first, outer, inner, last, or distributive property if you'd like to call it that. So we get x squared minus x plus 1. I'll go ahead and combine our like terms. So we have x squared minus 2x's plus 1. And then to finish this out, we'll go ahead and distribute that negative 2x cubed. So negative 2 x to the 5th power plus 4 x to the 4th power minus 2 x to the 3rd power. So as you can see, if we take the time and multiply this all out, it actually does fit into that definition of a polynomial function. No decimal fraction, decimals for our exponents or fractional exponents or negative exponents, nice positive integer exponents going on here. So that fits in and we can say, yes, that is definitely a polynomial. All right, the last thing that we should probably mention in this is talking about degrees. As far as degrees go, each individual term has its own degree, and that's based on what exponent the variable is raised to. So we could go through and say that first term has degree 5, second term is degree 4, and the third term is degree 3 based on those exponents. However, the other way to classify these and how we typically do this is the degree for the overall polynomial, the whole thing. So to find that, what you do is you use the largest degree of any individual term. So 5, 4, and 3, the biggest one is going to be degree 5. We'd say this is the degree 5 polynomial. All right, as we're thinking about polynomial functions, we tend to write them in what we refer to as descending order. All right, descending order simply means the highest power, the highest degree term is first, the next highest is next, and so on until you get all the way down. If you had a constant, it would be degree 0. Some other terminology to go with this. The very highest power, the very highest degree term, we refer to that as the leading term. So in our case, this would be negative 2x to the 5th power on this previous example. The leading coefficient is the number out in front, so in our case, negative 2. And then the degree, if you're just looking at the very first term in descending order, the leading term here, that will give you the degree for the entire polynomial. This is what we refer to as being written in the general form. All right, we'll talk about graphs in our next one, but hope this helps out on deciphering which ones are polynomials and which ones aren't. All right, good luck with it.